Let's solve this equation that's involving multiple angles. I have the tangent of x. The tangent of 3x equals 1, where x is between 0 and 2 pi. So let's go ahead and solve this out. First thing that might be good to remember is if we can start to remember what the period of the tangent function is. So let's kind of keep that in mind as we solve that. All right, the tangent of 3x equals 1. The only place that I remember that the tangent equals 1 is at the point pi over 4. So the only place that the tangent function is pi over 4 is at 3, or is the tangent is 1 is at pi 4. So 3x equals pi over 4 plus its period, which its period was just pi. So for every pi in pi past that gives me a solution to this particular tangent function. Let's solve that out. So we just get it for x. X equals divide both sides by 3, so I have pi over 12 plus n pi over 3. So there's my solution for all x's that make this particular equation where the tangent of 3x equals a positive 1. From there, because I wanted to know what are all the solutions just between 0 and 2 pi, so what we'll do is let's first begin and let's say that n is 0. So let's solve for n equals 0. This becomes pi over 12 plus 0 pi over 3. This cancels out or goes to 0, so I'm left with pi over 12. Let's solve at n equals 1. So I have pi over 12 plus 1 pi over 3. Let's get common denominator, so let's multiply this side by a 4 over a 4. So then I have pi 12ths plus 4 pi over 12ths equals 5 pi over 12. All right, notice that that solution also occurs between 0 and 2 pi. Let's look at n equals 2. Pi over 12 plus 2 times pi over 3. Multiply that again by a clever version of 1, which is a 4 over 4. So I have pi over 12 plus 8 pi over 12. And that equals 9 pi over 12. And I can reduce that down as well, down to, what is that, 3/4? 3/4 pi. Which again you'll notice is between the range 0 and 2 pi. And I can do this for all the values. N equals 3, n equals 4, n equals 5, and I can't remember if 5 or 6 is the last one, so let's solve for n equals 6. So that gives pi 12ths plus 6 times pi over 12. Oh, sorry, over 3. Multiply that by a clever version of 1, which I'm going to choose is 4 over 4. Pi over 12 plus 24 over 12 pi equals pi 12ths plus 2 pi, or equals, I can do it 25 12ths pi. That solution, 25 12ths pi, that is too large. That's beyond my range of 2 pi. So this is not a solution of this particular equation with these parameters, but at the point n equals 0, n equals 1, n equals 2, and then if I solve for 3, 4, and 5 in like fashion, those would also be part of that solution as well. So the answer to this particular equation has 6 solutions, 6 places where the tangent of 3x equals 1 within that particular defined range.